Here we go, 6-10. We're looking at similarity of triangles, okay? Trying to determine if two triangles are similar. Okay, they're going to introduce something called the angle-angle criterion, okay? Which basically just means, folks, if we have two triangles, if we can determine that they have two pairs of the same angle measurements, then those two triangles are similar, okay?
That's right.
So, let's take a look. Example 1, page 360.
How can you use angle measures to determine whether two triangles are similar? Think about this question during the lesson. Justin designs a pair of flags for a model sailboat.
I love sailboats.
The larger flag is 1.5 times the size of the smaller flag.
Ooh, that sounds like a dilation. So they took the smaller flag and dilated it 1.5 times, which just means each side length is 1.5 times longer. But
Are
guess
the
what?
angle measures 1.5 times bigger?
Well, based on what we did with dilations, no.
Oh.
How can Justin determine whether the triangles that represent the flags are similar? Remember, figures are similar if a sequence of rotations, reflections, translations, and dilations maps one figure onto the other. Begin by drawing and labeling triangles to represent the flags. We'll first draw triangle ABC. The measure of angle B is 46 degrees,
We know
and
those
the measure
two.
of angle C is 50 degrees.
Can we find this one?
Then let's draw triangle QRS. The measure of angle S is 50 degrees, and the measure of angle R is 46 degrees.
What does it look like maybe we could do? Do you think we need to have maybe a little bit of rotation, dilation? I don't know. Let's see.
Find a sequence of
Translation.
transformations that maps one pair of congruent angles to each other. Do you need to include a dilation in the sequence of transformations?
Well, yeah.
Select your answer.
Yes.
The two triangles are different sizes. Of the four main kinds of transformations we know, only a dilation can map a smaller figure to a larger one.
That's right, called an enlargement.
A rotation and a translation map angle S to angle C. First, rotate triangle QRS. Notice that angle S and angle C are now in the same position in each triangle.
Corresponding angles.
Now, translate the triangle so that points S and C coincide.
Wow, look at that.
They're the same angle. Angle R and angle B are corresponding angles.
Yeah.
Because angle R is congruent to angle B, side AB is parallel to side QR. The length of BC equals 1 1/2 times the length of RS. So a dilation from center C with scale factor 1 1/2 maps triangle QRS to triangle ABC. There is a sequence of translations, rotations, and dilations that maps triangle ABC to triangle QRS. So, triangle ABC is similar to triangle QRS.
That's awesome. Okay?
Yeah,
So
it is.
once again, they're going to go through this sequence, and that's just proving that it's true, that these two triangles are similar. We don't always have to do that, though.
Since we know the measures of angles in a triangle add to 180 degrees, we don't need to find the third angle of each triangle. We know they have equal measures.
But I want to.
That means if two angles of a triangle
Here it
are
is.
congruent to the corresponding angles of another triangle, then the triangles are similar. This is called the angle-angle, or AA criterion.
Okay, so I'll just explain what that just meant. Folks, if there are two angles, two pairs of angles that are congruent. So if I look at these two triangles, they both have a pair of 50-degree angles, and they both have a pair of 46-degree angles. If they have two pairs of angles that are congruent or the same, that means the two triangles are similar. We don't have to find the third angle because we know that third angle will be the same because the other two angles are the same and it's always the sum of the angles always equals 180. So to determine if two things are similar, all we got to do is prove that two of the angle measurements are the same in both triangles.
Not all three measures, huh?
Nope,
Okay.
nope. I mean, that's just extra work. Let's go to try it. We got to find some angles. Okay? And ask is, now, that little wavy sign there, that just means is similar to, is triangle XYZ similar to triangle LMN?
Maybe.
Well, we got to determine, does it have two pairs, or do the triangles have two pairs of congruent sides? Well, let's get the handy dandy little calculator. We got to find the measure of angle X. Well, again, I know these two plus, I'm going to put an X there. These two plus this one equals 180. Let's figure it out. So 92 plus 42, that equals 134. 134 plus what number equals 180? Well, we take 180 minus 134, and bingo, we get 46 degrees. Okay, this angle right here, 46 degrees. Bingo. Now, they want us to find angle N. Oh, well. Okay, so we will. Again, we know the three interior angles add up to equal 180. I'll put a Y there for angle N. I don't know why. Okay. Add those two together. 53 plus 92. This is 135 equal to 180. Okay, there you go. Isolate the variable, subtract 180 minus 135. Bingo. This comes out to equal 45 degrees.
Bingo.
Now, it wants to say, are these two triangles similar? Well, if they're similar, they have two pairs of congruent angles.
Two pairs.
So I can identify one pair of congruent angles. Can you identify another pair? 46? Is there a 46 over here?
Nope.
No?
Just
42?
one pair.
Is there a 4? There's only one pair. What does that mean? These things are not similar. Okay, let's go.
All right, example 2.
Example 2. With a try it. Bonus try it.
Yes.
Here we go. Are these two triangles similar? Explain.
Wow.
Well, I mean, if you want, Mr. Frick, you want to zoom or scroll down a little bit? I'm guessing there's not a next button.
No, there's no next.
Okay, here we go. Well, first off, folks, we can just look, again, if they're similar, two pairs of congruent angles. Well, the way it's labeled, I mean, and if we went through their information, it says because angle M is congruent to angle A, and angle P is congruent to angle C, that means they're similar. Why? Because they have two pairs of congruent angles. That's easy. Let's look at the next example in example 2. Example B. All right, we got these two triangles. We got a 42 degree and 85 degree. Look, they found the measure of angle Z by adding those two together and subtracting from 180. This angle Z is 53 degrees. They found angle S over here. They added these two together, subtracted from 180. This is 50 degrees.
Ooh.
Can you find two pairs of congruent angles?
Nope.
Once again, you can find one pair. Is that good enough? No. Nope. So those are not similar. Let's check it out. How about to try it? Ooh, look at this. Wow. Oh my. Okay, here we go. We got to prove whether or not these are similar or not. Once again, we got to prove that two angles are congruent. So, first off, we've got two triangles. It says X, Y, Z. And I'm going to put, XRQ. So, first off, What angle do we know is the same in both triangles? I'm going to put angle X is equal to or congruent to angle X. What type of angles are those? Well, they're on the opposite side of a vertex. Mr. Fricky back in 6-8 taught you guys about vertical angles. These two angles right here are vertical, which means they're congruent. So there's one pair. Now, is there a second pair we can identify that would be congruent?
I don't see any angle measures.
You don't see any angle measurements, but I'm going to help you identify a few things. Okay? These, they tell us, are parallel. Go back to 6-8. We got to use these lovely angle relationships we talked about. Okay, let me make a green little pen here, and let's look at angle QRX. Angle QRX. I hope you guys are thinking, because we just have to determine angle QRX is congruent. Well, can we go back to number 1? Just give the explanation. Okay? Let me write there. Those are vertical angles.
Yeah.
Okay, there's our explanation for our first pair. Sorry about that. Let's go now to the second pair. So we have angle QRX. Do you see any type of relationship that we can say or use to prove that QRX is congruent to another angle in this triangle?
Can you draw a transversal in there for me, Mr. Noel? Maybe
Well,
that'll help their eyes focus in clearly on what we're trying to
this
get.
line right there is a transversal.
Ah.
Because here's our pair of parallel lines. This line intersects those parallel lines. Here's my transversal. Uh-oh, I'm starting to see something. What would we call this compared to QRX? Inside of the parallel lines, on the opposite side of the transversal. So interior, opposite side, I think we use the word alternate. So we're going to use that relationship. We're going to call this angle X, Y, Z. Those two angles are congruent. Yes.
Yeah, baby.
How do we know they're congruent? What's the relationship? Pair of parallel lines cut by a transversal. Opposite side, we call those alternate. Interior
baby. Yes.
angles. And we just proved that those two triangles are similar. Because we proved that there are two pairs of congruent angles. Let's see what they got in store for us for example 3.
Okay.
I'm ready. Example 3, here we go. Boom!
Bonus video.
Bonus video.
If triangle ABC is similar to triangle EDC, what are the values of X and Y?
Woo!
The first step is to find the value of X. What relationship is formed by the two angles that include the variable X in their degree measures?
Folks, do you see that these two are what we call a linear pair or supplementary? Here's our straight line. These two angles combine to equal 180. Let's see how they use it.
The two angles form a straight line, so they are supplementary angles.
That's what we said.
This means that the sum of their degree measures
Scott must
is
have been listening to
180
us.
degrees. Simplify the equation to find that X equals 60.
Okay.
Now find the value of Y. What angle relationship can you use to write an equation for Y?
What do you think? Well, I bet you we're going to have to use this. And folks, if we look at the way triangles are named, okay, and they're saying these are similar. Angle A is congruent to what angle? E. Angle E. Okay? Angle E is 84 degrees. So we also know this angle is going to be 84 degrees.
Oh.
And let's see how they use that. Let's see. Inquiring minds
Want to know.
want to know.
Apply the triangle sum theorem. The sum of the three angles of triangle ABC is equal to 180 degrees.
Yeah?
We know that the angle measure of angle B is equal to 3 times y degrees. So now we need to find the measures of the other two angles.
We know this.
How can we find the measure of angle ACB?
Okay, now that's this angle, ACB. How can we find this angle here? Well, look for your relationship, opposite side of a vertex. What do we know? Those are vertical angles. So what is angle ACB? It's the same as this angle, which was 60.
Vertical angles are congruent. So the measure of angle ACB is equal to x degrees. We know that x equals 60, so substitute 60 for the angle measure in the equation. Can we conclude that angle A is congruent to angle E, so its degree measure is 84 degrees?
That's what we went over at the beginning. Hey, they're telling us these two triangles are similar at corresponding angles, A and E. They're congruent. So yes, we know angle A is 84 degrees.
Good job.
Yes, the triangles are similar, so corresponding angles are congruent. In the similarity statement, the names of the triangles show the congruent angles. Angle A is congruent to angle E, angle B is congruent to angle D, and the two angles at point C are congruent. We can also use transformations to show the congruent angles.
We could.
Reflect triangle ABC across a vertical line through point C.
Look at that.
Then dilate the image. Angle A maps to angle E, and angle B maps to angle D. So substitute 84 for the measure of angle A. Solve the equation to find that y equals 12. As we've seen, the similarities of the triangles determines that x equals 60 and that y equals 12, and it determines the degree measures of all the angles of the two triangles.
Bingo. All right. Nice video. I enjoyed that.
Yeah, that was good.
That was good. Find the value of x if the two triangles are similar. Okay. Well, once again, let's use some relationships. It tells us the two triangles are similar, right? So if the two triangles are similar, that means this angle and this angle and this angle. What's that mean? What do those little arcs mean?
Those are new. I don't think we've ever seen those.
We haven't
before.
seen those? Well, that means that these two, anytime there's a single arc here and here, that means those two angles are congruent. Okay? They're the same. So this is 90 degrees here. Holy cow, this is 90 degrees here because those are vertical angles. Now it says these two triangles are similar. Right? They're similar, which means this angle and this angle are congruent, and this angle and this angle are congruent, and these two angles are congruent. So that means this is 15x as well. Could we do it that way?
Yep.
So let's write an equation now. I mean, there's a lot of different ways we could do this, but let's write an equation to find and solve for the value of x. Well, I know the three angles together equal 180. Let's combine. Well, this is 30x. We take away the constant term, so let's get rid of the 90. That leaves us with 30x here on the left and 90 over there on the right. Divide by that coefficient, okay? 3. And your coefficient is equal to 3, or your variable, I should say, is equal to 3. There you go. Now, do I need to use words to explain? I don't think so.
Nope.
My work explains how we found the value of x. Okay, that takes care of lesson 6-10, angle criterion. Remember, two triangles are similar if they share two congruent pairs of angles. Great day.